Alright, so we're going to be talking about recursive sequences and factorials today. A recursive sequence is a sequence where you need to be given one or more of the first few terms. Okay, you need to be given first, second, third, just at least one. All of the other terms of the sequence are going to be defined by using that previous term. Okay, so I want to write the first 5 terms and then write the pattern, use the pattern to figure out the nth term. So an, what is an? Okay, so they give me that my first term is 6. Okay, then they tell me that ak plus 1 is equal to your ak, and then you're going to add 1 to that. So this right here is a subscript. This is a big. Okay, so when k is 1, I'm going to plug that in. So 1 plus 1 equals a1 plus 1. Okay, well right here I know what a1 is. They told me a1 is 6. So this is 6 plus 1. Okay, well when I add this here, I get a2 is equal to 6 plus 1, so a2 is 7. Okay, let's do the next. So when k is 2, I have 2 plus 1. So that gives me a2 plus 1. So I get a3 equal to 7 plus 1. Oops. And that equals 8. Okay, so if we look, I have 6, 7, 8. Let's think what should happen next. 9 and 10. So my first 5 terms are 6, 7, 8, 9, 10. Okay, now I need to figure out what a to the n is using this. Okay, if I look, they go up by 1 each time. So I'm going to have 1 n, because that's your multiple. And then to get to 6, I have to add what? I have to add 5. So let's try this out. When I plug 1 in, 1 plus 5 is 6. When I plug 2 in, 2 plus 5 is 7. 3 plus 5 is 8. 4 plus 5 is 9. 5 plus 5 is 10. Okay, so there is our nth term. That's how you can figure out what the 100th term if we wanted to know. Okay, part B is factorials. And we've kind of talked a little bit about what factorials are before, but not really that in depth. If n is a positive integer, n factorial is defined as the following. So n factorial is equal to 1 times 2 times 3 times 4 times whatever you're in. So the term before n times n. There is a special case that 0 factorial is equal to 1. Okay, that's the only special case. So basically, let's say if I had 6 factorial, that would be 1 times 2 times 3 times 4 times 5 times 6. Okay, I would multiply all of those together and get what that is. That would be 6 factorial. Okay, example 3. I want to write the first 5 terms and begin with n equal to 0. Okay, so the first 5 terms would be 0, 1, 2, 3, 4. My function sequence is a to the n equals 2 to the n over n factorial. Okay, so if I have a to the 0, that would be the first term they're talking about. I'd have 2 to the 0 over 0 factorial. Okay, well, earlier we put 0 factorial is 1. Okay, anything to the 0 power is also 1. So that would be your a naught. Okay, a1, I have 2 to the 1 over 1 factorial. Okay, well, 2 to the 1 is 2. 1 factorial is just 1, so this is 2. Okay, a2, I'd have 2 squared over 2 factorial. Okay, well, 2 squared is 4. 2 factorial is 1 times 2. Well, 4 divided by 2 is 2. Okay, 3, I'd have 3 squared times 3 factorial. So this would be 9. This would be 1 times 2 times 3. So 1 times 2 is 2, times 3 is 6. 9 over 6 can be reduced to... Oh, I wrote this in the wrong order. This is 2 cubed. Oops. That would be 8. So 8 over 6 reduces to 4/3. Okay. Then we go to our fifth term, a 4, so 2 to the 4th over 4 factorial. 2 to the 4th is 16, and 4 factorial will be 1 times 2 times 3 times 4. Okay, so that'd be 6 times 4 is 24. Okay, if I reduce that, that gives me 2/3. Basically, if you can reduce fractions, do so. Okay, because all of these can be reduced to this. So that's how you use factorials. Alright, let's flip this over and look at another example. I want to evaluate each factorial. So, example 3. I have 8 factorial over 2 factorial times 6 factorial. Okay, 8 factorial we can write. I like writing them in descending order. So 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay, 2 factorial is 2 times 1. 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. Okay, if I look here, all of these can be eliminated because they'd end up canceling out anyways. So this makes this problem much easier to deal with, because now I just have 8 times 7, which is 56, over 2 times 1, which is 2. Well, then 56 divided by 2 is 28. So that would be the answer to that expression. Okay, once you write it out like this, you'll know what you can eliminate, and it makes it much, much easier to deal with. Let's look at another one. Example 4. I have 16 factorial and 14 factorial. Okay, well, I don't have to write out every single thing from here. I can do 16 times 15 times 14 dot 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 3 times 2 times 1. Okay, you know what numbers go in between there. From here I'd have 14 times 13 times 12 dot 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 3 times 2 times 1. Well, all of these in between would cancel. Okay, so all I'm left with is 15 times 16 on the top. Well, when we multiply that together, we get 240. Alright, your assignment for this is A2, page 650, numbers 55 through 58 all, and 62 through 68 evens. Please let me know if you have any questions, and good luck.